Welcome back to the Object Stacking and Packing tutorial series. I'm your host, Thomas Tobin. If you haven't seen the previous chapters, I recommend going back to find them. For this portion of the tutorial, we'll be stacking objects and getting it working within Unreal. Let's get started. The next part of the tutorial series, we're going to look at stacking vertical layers now. So the next part of the challenge is exposing a certain amount of objects as being allowed to be stacked upon. So for the purpose of today, I'm just going to choose the tallest objects and say these can be stacked on. So I'm just going to put down a null node like we always do, and for organization to say this is the bottom layer out. Bottom layer pack out. Now, I don't think I follow my own advice here. Oh, I do. Okay. Keeping out or input as the very first word allows you to find them in the scene hierarchy quite easily. So we have our out bottom layer, and I'm going to add packed into there. So the first thing I want to do is look at these objects as individual kind of IDs. So I need to assign for each of these objects, what is its unique kind of like point? What is the information on the point that we can use? So I'm going to assign a ID for each of these point numbers. And just up by the attribute pack, I'm going to put down a attribute wrangle. And this is going to create an ID from the point numbers. So when we look at every single point, and we look at here, its ID correlates with the point number. And that can just say, for the object on the point later on, once we've scattered to it, it knows the point, it knows its information on it, and we can kind of like unpack by that. So let's go to our out bottom layer packed. I think the first thing I want to do is promote that ID to the primitives. So I'm going to do attribute promote and to ID point to primitive. And then I'm going to pack these by their ID. So the entire objects for each one of these pieces are separate packed prims. So we're going to turn on our name attribute, turn on ID, and connect that in. And we're going to get an error. So that error says invalid name attribute for partition can only support primitive string attributes. If we turn off create packed fragments, it fixes that error. And you can see we have 313 prims, or 313 points. And that's pretty much for each point that fit has a unique ID. We can go to this, we can see them. So we have our 313 packed objects in there. I'm going to make sure I transfer all my attributes to it, just so they're always keeping all their data along this. The final thing I think might be useful is putting a group node down and just grouping all of these objects at the very bottom and saying base layer. So from here, where do we need to go? Well, the first part of its problem is finding the tops of the surfaces. So we work the same way that we worked with the bottom faces. We group, we delete, and we go from there. This time though, I think I'm going to put this all within a feedback loop. So I can stack a layer, then find the tops of the objects, for example. From there, that's pretty much the entire loop done. Like we've placed points, we now stack boxes on that top layer. Again, now you have a new top layer, and you kind of have to, that's what the feedback loop is for, is constantly grabbing the top, stacking, and going as far as we can. So I'm going to put down a for loop with feedback. Now, the top node here is fetch feedback. So you know you have the right for loop type. I'm going to just increase that out for now. And our feedback iterations this time is how high do we want to try and go? So I'm going to say 3 right now, 3 layers. Now I would probably expose this as a parameter for our HDA and have that as a changeable attribute, because you could say 10, but maybe it can't actually stack to 10 high. And so having this just being able to be changed on the fly for each object is really good, because 1, you could randomize this value. And so every time you have one of these tools placed, they all kind of have a different height. But 3, the second kind of part of that is you can change the height at any moment. So again, like I said, we're going to take our object and I'm going to put 2 nulls down. So it's important on a feedback loop that you have to know the direction of where this loop is going. So my one side of the loop is the feedback side. So this is kind of going to be going in, it's going to hit the end of the loop, merge back in, and it's always going to be kind of the end result. Whereas the left side of my feedback loop is always going to be the processing side. So I'm going to name this processing. I'm going to put down a group node. And I'm going to name this top mesh. Again, keep by normals. 1, 0 this time. And we're grabbing our tops. Now you can see we're not grabbing anything, and that's because this geometry here is fully packed together. So this feedback side, we want packed. We want these objects to stay completely together, unaffected. Whereas on the processing side, we need to unpack this geometry so we can actually work with it. So I'm going to unpack, and ensuring, again, I transfer all my attributes over. So that's just here, putting a star in there to say, give me everything unpacked with all its attributes. Now, when we group the top mesh now, you can see we've grouped all of our tops. Perfect. I'm going to put down a group promote node. And I want to grab only the top of the tops. So I'm going to change this group from primitives to points. And that's going to allow me to grab the point, like point.y value, basically, the height of the point position. And I'm going to say top mesh. So we've promoted and we're just grabbing all of those top points. And primitive to point, perfect. I'm going to blast away anything that's not that. So our top mesh, going to delete non-selected, so we've grabbed our tops of those faces, and delete any unused groups, just to keep it clean along the way. Now, the first thing I want to do, and this is super messy, but I'm going to put down a partition node. Now, the partition node is going to create groups for us. And it creates groups by a rule that you've set. So you could say group by color, and it's going to create a group for every single unique color, group by alpha, or any other rule you create. But for us, we want to group by position. So I'm going to do @p.y. So for each position it has, you can see, it's created a new unique prim group. Now, the problem it has is it's doing _0 _4 blah, blah, blah. Now, we want to quickly clean that up a bit. And that's because it's, I believe, 0.4. So let's go to the position of these points. Just double check that here. So there you go. So it's grabbing that position and it's putting the 0, and it can't support space in the name. So it's putting underscore. So let's just put down a name node. And I'm going to do a name from group. And our group mask is anything. So any group, pretty much, because there's no other prim groups. Now you would want to specify if you knew the type, but we don't have any other prim groups here. So we can just say any group rename. And we're going to do 0 renames here. Sorry, number of namings we're going to put to 0. We're not naming a new attribute. We're renaming the attribute. So we're going to turn on number of renames to 1, have it enabled. And I'm going to put down a underscore 0 underscore star. And that's going to say rename anything that starts with underscore 0 underscore and then continues with any other word or character to just the star. So now when we look at this, they still are there, but we've now created a name attribute. And you can see we have 13 unique attributes. So let's go check that out. So inside the primitive attribute, and we look at our name, now we have a number that we can actually sort by really quickly. So you could do this in Vex, but again, the simplest way is always with notes. Maybe not the most efficient, but it allows us just to prototype quickly. So I'm going to put down the attribute promote, and I'm going to promote again our name, which is a number in the primitive from primitive to detail, and just grab our maximum. Let's do minimum, and we'll see where we go from here. I'm going to change this to min name, and keep the original number, just in case we want to sort from this in a moment. So we need to grab our minimum points. So I'm going to blast away now anything that is not that number. So we're going to do @name is equal to, and the function again is that detail function we did before, but this time it is detail s because it's detail of string. It's going to return a string value, 0, which means itself, and then I think I named it min name and put down another tilde at the end. So deleting the min name, we can now delete non-selected, and that's just going to grab the very tops. And that's perfect. So I'm going to go and create a few more surfaces that have the top surface. So we go to our attribute randomize, and this is what's setting our scale. We have to find that one. Here we go, iScale. And I'm going to increase that value, my stepping size. And I think if you change your seed to, there we go. So you can see clearly by changing the seed, you can really quickly change how many of these surfaces will actually be able to scatter on top of. Now, from here we have a unique situation. We have our geometry that we can pack within. I'm going to pack up these into, again, unique segments by their point value. So I'm going to put down a pack and put my name attribute to ID and turn off our create packed fragments and connect that in. So now these are 6 unique primitives. I'm going to work with the cluster points node. And this is going to basically say, instead of the entire geometry, like you could work with geometry, but in this case, I want to work with their center points. And I'm going to cluster together. So where is on each of these objects, it's their bounding object basically, where can we place these spaces? So there's a couple different approaches here. You could say for each of these clusters, if we said 3 clusters, for example, you could place your objects anywhere in this cluster. Now, we're going to get some interesting results if we place on top of your kind of overall just a single block. But as you go higher up, if we have shared segments together, so object segments that are kind of close together, you can see these two. Now, if you look at just the piece one by one and try to stack in here, it's going to fit within these bounds. But if we start to make this space between a shared space, then you now kind of increase the surface area, because an object, while it's not going to be placed in the open air and just hovering over nothing, it can be placed starting here and ending here. So this cluster points is going to allow us to work within these clusters and say, in this cluster, what do we want to do? How do we want to stack? So I'm going to set 3 just for now, and you could expose this parameter like anything else. I'm going to put down a unpack node, connect that in, and again, just transfer all our attributes back over. So from here, I'm going to promote my attribute of the cluster from my point to primitive. Down my cluster node. And that's going to say if later on, you probably don't need to do this actually, but if we had this pack node turned off and we did our pack cluster points from the other area, so let's see if we can test this and turn off. Yeah, here we go. So if you had no pack node here, you could, so this could be a switch, take the average of the prim and then have a single color for this one piece. Whereas when we pack, we're now looking at the entire section altogether. Just a different approach. I'll keep this node off for now and we'll see if we actually use it. And the final thing would be another nested for loop. So this is going to be for each pieces. And it's for each connected piece. And our connectivity is our cluster points that we've created. So I'm going to check what is the attribute that we're clustering here. So I'm going to name my attribute. Looks good. It's cluster, so I just have to change my piece attribute to cluster. If I single pass this, we should be able to see it. Invalid attribute specification cluster. So you could have it as piece elements points and not need this, I believe. Yeah. Okay. So if we work with points, you lose the primitive, of course. So we're going to keep it as a primitive. And then we get the entire object. That's why it's done. Silly me. So our for loop here now allows us to look, as I said, at each of these clusters that were created. Now, a way to kind of forge the gap between this geometry is using the shrink wrap node. Now, I think this is probably where the tool could be enhanced the most. Depending on how you build these shrink wraps is going to really create some unique kind of overlapping space here, if that makes sense. Because now we're creating a new unique spot that you could stack within. So if we, it'd be a little hard to visualize, but this square here, there we go. It's going to allow you to place an object here. Now, this is problematic in the sense that these are quite far away. So placing an object here with a random rotation, it may just miss this object. You might have floating pieces. So a way we're going to kind of fix this as a bootleg fix is putting down a transform node and just scaling the object down. So we're going to do 0.53. But again, you can see it's scaling from 0, 0 in the scene. So we just need to change that pivot transform to be $.cx, cy, and cz. And that's just going to change the pivot of how it's transforming to the centroid of each value. So you can see as we scale, going up and down here. And I'm just going to scale that up so it's just not near the edges of any of the surfaces. And that shared space that's kind of floating in the nothingness is now available to be placed on. And when we look at our single pass, if it's a simple rectangle like the square is, the shrink wrap's not going to change much, which is what we want. And our final object, if we look at the third pass, is a perfect cluster of space between these. So this is kind of the unique feature of grabbing tops, is now we can then have pieces that are a little more organically placed, as if a human placed it, instead of a robot that's just stacking vertically on top of it. Like it's not going to fit exactly on the surface. It's going to be kind of around this object. So from here, turn off single pass. So we've created our clusters. I need to delete the bottoms. So this time, instead of putting the group node, I'm just going to put a delete node and grab the bottom here. And this is because the shrink wrap node, you can see, is generating a geometry that actually is 3D. Don't know if I can, it's fine. So deleting our geometry, anything but the bottom, now we're just getting a single plane. It looks to be in the right rotation right now, so I'm going to leave it and see if I have to reverse it later on. Now, something we have to look out for, and I didn't cover this on the previous stacking, I believe. If we look at this mesh, and go to UV layout, sometimes you could be organically, it's kind of hard to see here actually. I'm going to change the scatter line rotations to something more linear. Doesn't appear to be doing it. So I'm going to undo that. Let's go to 0. No, it doesn't seem to be doing it, but I'll fix for it anyway. So the one thing you kind of have to be aware of, sometimes this UV layout, and this may have been patched, just don't know it, but I have experienced this quite a bit, is it will try and pack within each of these as a unique square space. So we'll pack within this prim number as a space, and it's going to pack for each one into that. So we just have to remesh this object. So now you're breaking up these strong distinct lines into more organic spacing. So even if it looks at a single triangle, you're not going to be able to see, oh, you can't see my hand waving in real life, but a cutoff from here to here. So same thing on these primitives here. We just need to put down a remesh node. And I think the target size is probably fine for now. You could probably shrink this, but keep it as it is. Now, the next step is a UV layout node. Because we need to place our objects in the space, again, we're just merging in our objects from before. So object merge. I'm going to scroll up and find the exact same one we used as before. So I'm going to my unpack 8 and grab that. That's just before the UV layout. So we're grabbing the exact same data. And that's our objects that are being just scattered as much into that space and they don't fit. So from here, just gonna connect that into our UV layout as our geometry to pack and view that. Again, doesn't have any of the same information, so we can probably just go up to this UV layout, copy it, and use it exactly as it is. So now our UV layout node is going to try and pack into those spaces like we had before. Now I've lost my rotation, so I'm just going to go up to my scatter line node and go 360, so we get a bit of randomness between them. Perfect. So do we have varying scales between? Doesn't seem to be. Oh, it looks like we do. We have varying scales between it, so I don't need to randomize my I scale, so it's already being done. However, you could, if you wanted to, have another unique and just override it here. So attribute randomize, and you could say primitives, I scale, and the objects that are stacking higher. So I'm going to do a uniform discrete again. Could maybe stack 0 to 1 and by 0.25. So they vary a decent amount between here. And we need to delete, again, our non-packed objects. So that's all of those objects that are just off to the side. And we have our 2 areas. So I'm just remeshing, just checking everything. So we fit as much as we can into there and there. Perfect. And then for here, I think we should be good to use these. Do they have a unique ID? Let me check here. But when they come in, are they a primitive ID? Yeah. Yes, they are. So when they come into this for loop, they're primitive ID. So we just need to promote that back up. So ID, point to primitive. I'm going to delete the original because I don't need it. So each of these pieces are keeping them the same. And like we said before, anything that comes into the loop needs to be packed. So we're going to pack together again. And name attribute is ID. Turn off create packed fragments. And now we have these as each single object is a packed object. And I'm going to put down a merge node. So at this stage, you're pretty much done the processing for the layering. And all you have to do is bring this to the very bottom, because we're almost at the end of this for loop here, the feedback node. So feedback nodes are kind of annoying because they're quite hard to visualize. You can only use the stop condition. Because if you looked at single pass, you looked at, say, pass 3, it can't exclusively look at a pass. It has to figure out all the passes before it until it gets to, say, pass 3. So you would have to do a stop condition of 3 if you wanted to preview this for loop. So once we're in this merge, we can just overwrite that and connect that in. So straight away, you can see we've packed vertically as much as we can. Now, this is where we run into this problem of we have geometry, while it looks good overall, one, very hard to see. So I'm just going to unpack because the normals are not there. There we go. So because of the way we place this geometry and we've used clustering, I've set a hard cluster value, so it always has 3. So if we use our stop pass, we're going to find what layer is this. Layer 1, so this is loop of the 1 is placed in this layer, and then loop 2 is placing this layer, so that is 2. So I believe stop condition should be 2 here. There we go. And I'm going to look at what is coming in. We have a bunch of objects, partition, blast away, so we have quite a few top surfaces here. And I think I'm going to increase how many clusters I have in a semi-procedural way. So right now, we're sharing quite a few. I think for the example today, I'm just going to say every single object will have a unique cluster. So I'm going to add 2 spare inputs. The first is just going to be my function of endpoints. How many points are the total? And that's going to be points of how many objects. So this is just before our pack. So I'm going to put in my blast. And then my clusters node is going to be channel spare input 0 times 1.5. My partition. So this is just saying, see if I can visualize how many number of points are there. So there's 24. So there's just always going to be enough points. Is basically where I'm getting at here. I just want more than there's pieces. So for each of these sections, they're always going to have a unique cluster, and that shrink wrap is just going to be a single piece. So we're not going to have any hovering on this section, I believe. So let's go to the end of this for loop. I'm going to go to my unpack. Make sure all my loops are not on single pass. Turn off my stop condition. Currently, we're uniformly packing onto each island. This does avoid the problem of floating pieces. However, these floating pieces actually serve a really good purpose in the next episode. And that's because we can easily fix them when we simulate the pieces. So in the simulation stage, you're able to have these floating pieces drop to the ground and create a lot more organic placements. And so for the next part of the episode, I recommend you expose this cluster value to your HDA, and it's going to allow you to create these stronger looking results because now you have pieces that naturally would fall just like in real life. For now, I'm just going to set this value to 1.5 times the amount of points, and this will just create a unique cluster for every single top perim. But again, expose that value and you can access this figure at any moment. So going down, we're going to look at this unpack node. I think I can get rid of this at this point. And we need to see what do the objects look like. So this would be if you had from any other DCC, this is kind of how it would work. So it's going to be another object merge. And I need the I scale, so I'm going to attribute promote. So our primitive I scale to P scale, so that our copy to point node will understand the I scale. And I'm going to copy to point. These are our target points, so that's our objects. And this is going to be our high poly out. So if we go back up, that's going to be this right here. So select my object merge, go to it. And I think we're going to have to make a few changes to make this work. So looking at our high poly merge, it is very large. So, and that is because I believe I scaled my sizing 6.36. Okay. So I'm going to copy this value. And maybe we'll get to that in a moment, actually. Copy that in. And we need to make sure our variant is turned on. We're packing and instancing. We are working with packed geometry here. So why are our variants not packing correctly? In order to determine that, I think we have to look at our high poly out. So right at the top of our graph. So from here, I need to check, does this have a variant? Well, first of all, no, it doesn't. So there's not even, doesn't know what this variant is that it's trying to copy to. So we're going to do a attribute rename. And that is class, because it has a class. Let me just check if it's on primitive. Yes, it is. So this has to be primitive class to variant. And then we need to make sure this is on the right points. So I'm going to do attribute promote. And I'm going to do variant from primitive to point. So I believe this needs to be a point value. Let's go all the way down to our copy to point. And we're getting a bit of a chunky space. So if I put down a transform node at the very bottom here. Now I know I'm jumping up and down a lot. And I shrink this real small. If you get to a relatively small number, you can see, hey, that looks pretty close. So what has gone wrong here? Well, at the very start of our object, we changed that scale. And we had a transform node that was setting the first scale of these objects. We simply need to undo this. So I'm going to do, well, like I said before, copy this parameter from the uniform scale. And I'm going to have paste relative reference times by 0.01. So that's just scaling down these objects in the complete opposite direction. So right here, let's check. Do we have it looking very similar? I think we're slightly off still. So it doesn't seem like we're picking up anything taller than the original objects. But they seem to be inside. So it took me a while to find it. But I finally realized the reason we're only copying on the base layer and not the bottom, the tops, is because on our pack, at the very bottom of our for loop with feedback, we are not transferring all our attributes. So this is kind of why I tried to highlight earlier that we need to make sure this is one of the things we're doing. It took me a long time to find the problem of why I was having missing pieces. And that's really just because my attribute randomize I had set from 0 to 1. And this needs to be a number anything but 1 because it's just saying at the end, its scale can't be 0, right? So it has to be, say, 0.2. Now it fills in the missing objects. In certain cases like this, sometimes the uniform scale also, just because of floating point errors or any other type of error, maybe I made something along the way. Sometimes it's not perfectly scaled. So I just changed this figure from 0.01 to just something just smaller, 0.01. And now all the objects line back up. So if I change this to go very right back up to the top, my DCC choice, we went to our shader world test geometry. Back this out. This should now, there we go. So if you have high poly geometry coming in, so this is a good example of this test geometry coming in, it's going through the loop, coming down, and the high poly is what we're visualizing again. So this could be the tool working like finished, done with the object merge at the end here. But this is not the way I recommend doing it for Unreal. And so while it works for other DCCs, say Unity or Maya Max, we're going to keep going with this tutorial and look at quickly a view on simulation, but then also how do you get this working within the data tables that we had used originally, because we want to use all that same data, right? So I'm going to go back, turn off my DCC choice switch, and let's proceed from here. So at this moment, I'm just going to put an output node down and see what it looks like within Epic Games, within Unreal Engine. To go over, we have our high poly objects. However, you can see it's not instancing any of the data yet. So we're going to get there in a second. So I'm going to cut that output. And I'm going to make sure I just keep transferring my P-scale and my orient, because I think I'm going to need that. P-scale, orient. And this is going to be just basically transferring for our instancing. The very last part of the tutorial is getting this data working within Unreal. So once we have our attribute transfer, I'm going to put a null node down. And this would be where you put any simulations. For now, I'm going to leave this. And I'm going to put down a node that's a switch node. Come off, and then have my second input. So if we wanted to go the simulation route after this, otherwise straight from here, we can then go on and instance within Unreal. So I'm going to put down a clean node. And we're going to remove pretty much everything, but we want to keep the original stuff from the data table. So I'm going to say not my normals, not my up, not my orient, scale, P-scale, and then these are going to be from my data table, Unreal instance, and if we have Unity instance. Make sure my pack and instance is on, so we're working with packed prims. Looks to be so. And I'm going to do a for each connected piece. My connectivity is my primitive, yeah. And in here, I'm going to group together all my pieces. I'm going to put down a attribute wrangle node. Call this center low. So I need a vector, and this is just my min and my max. The bounding box for each of these. Then create a vector for the center point, and that's min max divided by 2. Create my combo. For each object, we've created a center point, and instead of the axis align kind of node, we've now done the center. So I'm just going to look at my object here. So for each of these, I need to create a point instead of the center of them being like their centroid. I need that centroid to just be at the very bottom of it. So that's why we've done our min-max, and then our combo vector is basically saying our centroid of x, centroid of z, and then our bottom value for our y. I'm going to blast away anything that's not group 12, or blast away everything but it. So we just have our 1 point. And I'm going to do attribute transfer anything from this original group back in. So that's just getting rid of anything that we don't need, making sure we have all the information back on this. If I finish this loop, so we've now created a bunch of centroid points on these objects. If we look just before, after, should be good. I think I need to make sure this is not running over points, but running over detail. Looks to be good to me, and we'll come back to that if it doesn't work in a moment. So this is just going to be the final output. I'm going to go here, check that it has our Unreal instance on here. Go to the points. Let's check out what our geometry has. It has our Unreal instances. Looks to be good. There's a couple of objects that are missing a p-scale. We'll look into that in a moment. I wonder if my math here is incorrect. Okay, it was just a quick correction in my Vex code. We're just going to make sure you have it all correct as seen here. So now that we have this running through, just had to double check that on the object here, that your center low is, as you can see, creating a point in the centroid of the object. When I was doing it, I think I forgot the plus, and so I was placing it off on the side. But now that it's correctly placed, this pretty much just sets up the centroids at the very top of these meshes. When we look at our output, V5. Almost there. So at this point of the tutorial, the tool is almost there, and it took me a little while to debug this. But there's just a few changes that we need to make to ensure that we're keeping the right scaling and any other attributes along the way to make this a finally finished tool. So I'm going to go back to Houdini, and the first change we want to make is in the center low, we're going to set this to minimum.y. So I'll show in a bit why this is necessary, but for now we'll move on. Now, the main thing that is screwing up the Unreal side is the scaling is not copying over to be the same. And this is due to we go right up to the scatter and align node. By default, one of the attributes it has turned on is the radius attribute p-scale. Now, originally I showed this off by affecting the density scale, which was also affecting the scale of the points. So if we view the copied point, we can now change, if we turn off that radius attribute, the p-scale, we can change this density scale without affecting the scale of the pieces. Now, this is making the math a lot more simple because we only have to calculate for one type of variable in this sense. If you're multiplying the p-scale against this value, now you have to worry about the scaling being affected in here, and also if you affect it farther up in the graph. So turning off the radius attribute on the scatter and align node fixes that issue. The next thing we need to do is ensure that we're grabbing the right object from this object merge 10 node. Now, comparing the attributes, when I middle click, you want to make sure you have the same type of attributes, first of all. But we're going to unpack to the unpack 8 node. So I'm just going back up. I believe I previously had the unpack just below the attribute randomize. So I was attribute randomizing on the unpack node. However, it seems to work better actually in the sense after the unpack node randomizing. So I'm just going to make sure the unpack is above it, and I copy to that. I object merge into that. Sorry. The final thing, and I'm going to show what we have in Unreal right now. We're almost there on these points. So you can see the packing is working correctly. And this confused me for a long time, but it looked like we have floating pieces. And this is actually because this object, the bounding box, is taking into account this little strap. So there are a couple different ways to approach this. The first way would be just change the bounding box size in the test data table. Now, with LiveLink, it doesn't seem to bring in a new data table automatically. So the quickest way for me to do this was, if I go right up to the top of the graph, you can put down an attrib string edit. And this just let me go in the geometry spreadsheet. And just before, if I show, there were 2 values. And this is because that is the height of, yeah, here we go, Unreal data table for height. 59, obviously, in the thing is just a little bit too high. So if we offset this by 5 or so units, I think I did 8 here actually. So now I've overrode the attrib Unreal data table height. I've searched for any value that's 59, and I'm just setting it to 51 now in this case. So now you can see that value has been overridden. And if I go right to the bottom of the graph again, and go to Unreal, bam, we've locked it down to the ground. Now it doesn't matter if there are little pieces that are intersecting. And we have all the Unreal instancing done. This pretty much concludes the part of the tutorial looking at object stacking and packing. For the next part of the tutorial, we'll do a quick demonstration of simulation working with this. And that's pretty much it. We'll see you in the next episode.